Okay, now we're looking at the volume of the cone, which is 1/3 BH, where the area of the base is a circle pi r squared. We're going to plug everything into it that we know. Radius is 10, its diameter, so radius will be 5, height is 12. And let's see if we do any of this in our head before we get to the calculator. 1/3 of 12 is 4. 5 squared is 25. 4 times 5 is 100. 25 is 100 pi. That's the answer. No calculator needed. About the volume of a hemisphere. Now the volume of a sphere is 4/3 pi r cubed, and r is 15. So 15 cubed is 4/3 times pi. So 15 cubed, I don't know what that is. 15 to the 3rd power. Okay. So 4/3 of that require us to divide it by 3 and multiply it by 4. And ultimately we need to divide it by 2 because it's a hemisphere. So that's our answer. Okay, on to the next one. This is a triangular prism. And the only thing tricky about it is they didn't give us the base and the height. So this is 17. So this is 17. So we're going to use a squared, b squared equals c squared. So 8 squared plus b squared equals 17 squared. And then we're going to find the value of b, which I'll do off screen for a second. So b ends up being 15. Okay, so great. So that means this is 15. Now hopefully you can see that the volume of this will be equal to the base times the height. And the base is a triangle where we have 1/2 base of 8, height of 15. We've calculated that. We don't know the height of the triangular prism, but we do know the volume from right here. So we have an equation with only one letter. We're going to solve it. We're going to do that by, let's see here, do all this in the calculator. 768, get rid of a half, I'll multiply both sides by 2. Get rid of 8, we need dividing by 8. Get rid of 15, we need dividing by 15. My h equals 12.8. Okay, centimeters. The next one says to find the volume of this trapezoidal pyramid. So you can see a trapezoid on the bottom. And it doesn't say find it says find the height. They give you the volume. So volume equals 1/3 base height. 1/3 is because it's a pyramid. And let's be a little bit more specific. This will be 1/2 base 1 plus base 2 times the height of the, so little h is the height of the trapezoid, and then there's a capital H. But everything we know. 896 is the volume. 1/3. We have a 1/2. We have a base of 20 and a base of 12. We don't have little h, but we do have capital H, which is 24. Let's see if we can clean any of this up. 1/3 plus a half is a 1/6. So 1/3 times a half is a 1/6. A 1/6 of 24 is 4. 20 plus 12 is 32. Okay, things are looking pretty good here. Now we need to go to our calculator, solve for h. So we have 896. Let's divide by 4. And then divide by 32. that's h, 7. So the height of the trapezoid is 7 centimeters. If that went too fast, rewind it. Listen to it again. Watch it again. Find r, the radius of this cone, if they give you the volume. Well, the volume of a cone is 1/3 BH, where B is a circle. That's the area of the base. So again, they've given us the volume, 1728 pi, 1/3. Don't know the radius, but we do know the height of this cone is 36. So we're going to do everything in our power to make all this go away. First things first, divide both sides by pi, and the pi is gone. Let's go to the calculator and do the rest of it. Notice how I do, I sort of get rid of things one at a time. So I start with 1728, I got rid of the pi's. Now to get rid of 1/3, I'm going to multiply by 3. To get rid of 36, I'm going to divide by 36. So at this point, I have 144 on the left, and r squared on the left, right. If I square root both sides, I get 12. That is the radius. Now we're on to this one. Find r if the volume of what you're looking at is 256 pi. This is really interesting because this is the volume of what looks like a hemisphere, but it's not even a whole hemisphere, it's 3/4 of a hemisphere. So we're looking at 3/4 of half of a circle. So we're really 3/4 of half is really 3/8 of an entire volume of a sphere formula. So we're going to take the volume of a sphere, which is 4/3 pi r cubed, and we're going to multiply it by 3/8 because we don't want the whole volume of a sphere. Okay? And they want to know what the radius is. We have everything we need. 256 pi is the volume. 4/3 pi times radius cubed times 3/8. So let's kind of do a little bit of canceling and reducing first. Divided by 3 and times 3 on the same side cancel. 4 and 8 is really just 1/2. So now let's go ahead and go to the calculator. We can also get rid of the pi's. Excuse me, I forgot to get rid of the pi's on both sides. So we have 256. To get rid of a half, we'll multiply by 2. That's 512. So we have 512 equals r cubed. Now, we're going to need to take the cubic root of both sides, which can be done on the calculator. Let me show you how to do that on the calculator. We've got 512, so we're going to get math. Go down to option 4. And then you can either type in 512 or you can pull second answer. And it pulls up the previous calculation. And the answer is 8, so the radius is 8. One problem on this page says find the volume of a regular hexagonal prism that has a cylinder drilled from its center. Each side of the hexagonal base measures 8, the height is 16, the cylinder has a radius of 6. This is really difficult if you don't draw it, so we're going to draw it. I'm going to take a second, pause the video, and it'll just appear. Okay, so let's go ahead and label it. It says the height of the prism is 16. It says the hexagonal base measures 8. These are all 8. It also says that the radius is 6. And find the volume of the prism that has a cylinder drilled from its center. So the cylinder has been removed. So we need to find the volume of the prism. So we need a base times height, and the base is a hexagon. So we need the 1/2 NAS formula times the height. This is everything we'll need. 1/2. Number of sides, hexagon. Apothem, we do not know. We're going to need to calculate that. The side length is 8, and the height is 16. Now let's go back to that apothem for a second. This is a hexagon. So let's take a better look at what a hexagon we can get out of it. First of all, from the center we can draw a bunch of triangles. There are 6 of them. This is 8. And these all measure 60 degrees. So I'd like to take that 60 degrees, cut straight down, creating a 30 degree, or a 30, 60, 90 triangle. This is now 4. The apothem's right here. We need to take the apothem. To get the short leg to the apothem, we'll take 4 root 3, because that's the long leg of a 30, 60, 90. So this apothem is 4 root 3. Okay? Get rid of that for a second. Now, let's calculate that volume on our calculator. 0.5 times 6 times 4 times the square root of 3 times 8 times 16. It's 235 about. Okay, so we have 235. Now we need to subtract out the volume of the cylinder. Now the cylinder, we'll just do off to the side here, is just pi r squared times h. It's 36. 6 times 6 is 36 pi times 16. I don't know what that is, so let's subtract that out. Subtract 36 times 16 times pi. You get an approximate answer. Whoop, that's totally wrong. Can't be right. Hold on a second. Okay, if I'm a mistake, this was 2,660 for the volume of the prism. Take away this volume of the cylinder. 2,660. Take away 36 times 16 times pi. We should have our answer. 850. And I'm getting an answer of 850, which is different than the answer sheet connected to the packet. So we may have to look at this one in class, double check each other. But I think I'm right here. Could be wrong.